Dear students, in this video, we have to discuss certain previous questions related to some important topics. The first question is related to quantum mechanics. A simple question. The Heisenberg equation of motion for momentum for a system with the Hamiltonian h is equal to p square by 2m plus v of r is. The options are given. Students, here h is Hamiltonian, p is the momentum, v is the potential energy. To solve this equation, to solve this problem, we should know the Heisenberg equation of motion for momentum. What is that? We know that equation, IH cos dp by dt is equal to commutator ph. Okay, this is the Heisenberg equation of motion for momentum for a system. Okay, then here h is equal to the Hamiltonian h is equal to p square by 2m plus v of r. This is the Hamiltonian in 3 dimensions. Consider for the simplicity, we consider this equation in 1 dimension. Then this equation become px square by 2m v of x. Okay, consider the Hamiltonian for the system in 1 dimension. Then rewrite this equation as dp by dt is equal to, we want to find out the equation for dp by dt. Okay, from this equation dp by dt is equal to 1 by ih bar or ih cos commutator ph. Okay, in 1 dimension dpx by dt is equal to here px h. It is equal to 1 by ih cos or ih bar px. Actually this is the operator px and this is the Hamiltonian operator. Okay, then px square by 2m plus px. Okay, split this commutation bracket. 1 by ih bar or ih cos px square by 2m plus 1 by ih cos px v of x. Okay, surely by the equation for commutation bracket, this is equal to 0. Okay, px into px square by 2m minus px square by 2m into px, it is 0. Okay, then dpx by dt is equal to what is that? Simply 1 by ih cos or ih bar px v of x. Okay, then we find out the value for this commutation. For that, multiply that with a function psi. Okay, then this is equal to px into v of x into psi minus vx into px psi. Okay, commutation ab is equal to ab minus ba. Okay, then what is actually the momentum operator px? Px is the momentum operator, which is equal to minus ih cos minus IH cross dou by dou x. Okay, substitute this equation here. Then Px, commutation Px V of x into psi is equal to what? Minus IH cos dou by dou x of product of two functions V of x into psi minus V of x into x is minus IH cos. Minus into minus, which is plus IH cos dou psi by dou x. Okay, then find the product of differentiate this product minus IH cos dou V x by dou x into psi minus IH cos V of x into dou psi by dou x. Is it? Okay, then V of x into IH cos dou psi by dou x. Okay, then cancel. So P of x, so Px into V of x into psi is equal to minus IH cos dou Vx by dou x into psi. Okay, that means the operator Px V of x is equal, the commutation Px V of x is equal to minus IH cos dou Vx by dou x. Substitute this value here. Then dpx by dt is equal to 1 by IH cos into minus IH cos dou Vx by dou x cancelled, which is equal to dpx by dt is equal to minus of dou V of x by dou x. This is the value of dp by dt in one dimension. Then what is this value? dp by dt in three dimension, which is equal to minus of dou by dou x plus dou by dou y plus dou by dou z, which is del. Okay, minus del V of r. So the answer is option A. Our next question, it is related to a particle confined in one-dimensional potential well. A particle is confined to the region, the length of the region is given in one dimension. If the particle is in the first excited state, see, the particle is not in ground state, it is in first excited state, then what is the probability of finding the particle where the probability of finding the particle is maximum? Okay, at what distance from the either end of the well the probability to find the particle is maximum? For that, consider, you should know about the one-dimensional potential well. Okay, I will explain briefly about one-dimensional potential well. This is the one-dimensional potential well. Our particle is confined in a one-dimensional box. Here the x-axis is taken. Here x equal to 0 and x equal to L. Okay, the height of the potential is infinity. Okay, width is finite, x equal to 0 to x equal to L. Particle is confined inside this potential well or inside the box. Okay, then here this is n is equal to 1, which is the ground state. Okay, the wave function for the particle wave function for the particle which is confined in this box is given by root 2 by L sine n pi x by L. Okay, simple equation. The wave function associated with the wave moving with the particle inside this potential well or inside this box is given by psi is equal to root 2 by L sine n pi x by L. Okay, here n equal to 0 is not allowed. Okay, can never become equal to 0. N equal to 1, 2, 3, etc. N equal to 1 means the particle is in ground state, and first excited state means n is equal to 2. Okay, for first excited state, n is equal to 2. Okay, then which means particles, suppose this is n equal to 2. Okay, we have to find out where is the probability of finding the particle at, where is the probability of finding that particle is maximum at this stage. Okay, that means at what distance from this side or that side, from that side, the probability is maximum. Okay, for that, for first excited state, this psi is equal to psi is actually psi n. Psi of 2, which is the wave function for the particle existing or occupied at n equal to 2. Okay, then psi 2 is equal to 2 by L, root 2 by L sine 2 pi x by L. Okay, the next, what is the probability? How the probability can find out? Probability is actually the integral psi square d tau in 3 dimension, and which is equal to integral psi square dx in 1 dimension. Okay, the integration is from x equal to 0 to x equal to L, x equal to n. Okay, this is the probability. The equation to find out the probability is actually the normalization condition. Okay, p is equal to integral 0 to L psi square dx. Okay, to find out that integral, first I draw a graph between x, that means the length of the potential well, and psi. Psi versus what is the nature of this psi versus x graph? At x equal to 0, for n equal to 1, x equal to 0, see this equation, psi 1 is equal to root of 2 by L sine pi x by L. Okay, then at x equal to 0, psi 1 is equal to 0. At x equal to L, sine pi L by L, which is sine pi, which is equal to 0. Okay, so at x equal to 0 and at x equal to L, the wave function psi is equal to 0 if the particle is occupying at n equal to 1. Okay, then this is the length where x equal to L by 2, middle of the well. Okay, then what is the value of psi 1 at this point? X equal to L by 2, which is sine pi by 2. Okay, that means psi 1 has the maximum value at L by 2. So the nature of the graph or the nature of the wave functions like this. Okay, then for n equal to 2, psi 2 is equal to root of 2 by L sine 2 pi x by L. Is it? Then at x equal to 0, this value is equal to 0. Okay, at x equal to L, this value is equal to 0. And what is the value of psi 2 at x equal to L by 2? Which is also equal to 0. Okay, so the value of psi 2 is equal to 0 at this point, and this point. Then, what is the length here? The middle point of x equal to 0 and x equal to L by 2. It is L by 4. Substitute the value. We will get sin pi by 2, which is 1 maximum. Okay, and this distance is actually the middle point of L by 2 and L. It is 3L by 4. Okay, it means substitute this value here, we get minus value. Okay, the nature of the variation of psi with the length, x at n equal to 2 will be like this. So this is the variation of psi along the length of the potential well at two different states. Then what will be the nature of this plot if we take psi square instead of psi? See here, x equal to 0, x equal to L, x equal to L by 2, okay, and here n is equal to 1, n is equal to 2, okay. Yes, it takes psi square instead of psi. Okay, then here psi is equal to 0, psi square is equal to 0. Psi is equal to 0, psi square is equal to 0. Psi has maximum value and its square. So the nature of psi square for the particle at n equal to 1 is like this. What is the meaning of this graph? The probability of finding the particle at x equal to 0 and x equal to L is 0 if the particle is in ground state. The probability of finding the particle is maximum if the particle is at ground state. The probability of finding that particle is maximum at the middle of the box. Okay, the probability of finding the particle increases from this side and get maximum value at the middle of the box and gradually decreases to 0. Then, what is the case if the particle is at n equal to 2? See here, x equal to 0, psi equal to 0, psi square is equal to 0. Okay, x equal to L by 2, psi is equal to 0, psi square is equal to 0. X equal to L, psi is equal to 0, psi square is equal to 0. Okay, and here L by 4, at L by 4, psi has maximum value and its square also gets maximum value. Okay, here psi has negative maximum value but its square is positive. Okay, that means at x equal to 3L by 4, psi square has maximum value. Okay, the nature of the graph is like this. That means if the particle is existing at n equal to 2, that means in the first excited state, the probability, the places where the particle can see, or the probability to find the particle is maximum at two places, at L by 4 and at 3L by 4. Okay, if the particle is existing at ground state, the places where the probability is maximum is only one place, it is the middle of the box. As the excited state increases, the places where the chances to find out the particle is increases. Okay, then, so what is the question? if the particle is existing in first excited state, the probability of finding particle is maximum at L by 4 and 3L by 4. Okay, that means option D is correct. Okay, from this explanation, I think clear that how to find out the places where the particle can see in a particular excited state. Okay, in this manner, in a similar way, you can find out the places to find out the maximum probability or to the points where the probability to find the particle is maximum at n equal to 3, n equal to 4, n equal to 5, etc. etc. Okay, our third problem, it is related to the previous question. The question is that in the previous question, if the particle is in the lowest energy stage, then the probability of finding the particle in the region. Okay, you find out what is the probability of finding the particle in this region if the particle is present at the lowest energy state, which means the particle is at ground state. Okay, recall the previous case. I explained that variation of psi square with the distance A. Okay, x axis A, then x equal to L and x equal to 0. Here the middle of the box say x equal to L by 2, L by 4, 3L by 4. Okay, then this is n equal to 1, and if you take psi square along y-axis, the probability of finding the particle is 0 at x equal to 0 and x equal to L. Okay, and a maximum at a L by 2. Our question is that what is the probability of finding the particle if x is greater than 0 and less than L by 4? That is you should find out the probability of finding the particle between this region. For that, what is the probability? Probability is actually integral psi square dx in one dimension. Here you should carry out the integration between x equal to 0 and x equal to L by 4. What is psi? Psi is actually root of 2 by L sine n pi x by L. Since the particle is present at n equal to 1 sine pi x by L. Okay, then substitute that value. P is equal to integral 0 to L by 4 psi square dx, which means integral 0 to L by 4 psi square, which is 2 by L sine square pi x by L dx. Okay, on calculating this integral, we can find out the probability of finding the particle in this whole region. Okay, then which is equal to here 2 by L integral 0 to L by 4 sine square theta, which is 1 minus cos 2 theta by 2. Okay, 1 by 2, 1 minus cos 2 pi x by L dx. Is it? Then it is 1 by L. Okay, taking outside 1 by 2 to cancel the 1 by L, splitting the integral 0 to L by 4 1 dx, which is bx, minus integral 0 to L by 4 What's that? Cos 2 pi x by L dx. Okay? Equal to 1 by L. This is actually integral dx is x. X within the limit is 0 to L by 4 minus sine 2 pi x by L by 2 pi. Okay, within the limit 0 to L by 4. Okay, then. One by L. This is L by 4. Okay. L by 4 minus L by 2 pi. Applying this limit sine 2 pi by L. 2 pi by L by 4. Okay. Then minus sine 0 to 0. Okay. Then it is equal to LL cancelled 1 by 4 minus LL cancelled 1 by 2 pi by 2 sine pi by 2. Okay. So 1 by 2 pi 1 by 4 minus 1 by 2 pi. So the answer is the first option 1 by 4 minus 1 by 2 pi. Simple question, simple way.